Okay, first of all, I'd like to thank organizers for their inviting me to such a nice workshop and their hospitality. Today I'll talk about association schemes, and someone may ask why they are small, and because they are actually small, and the word of small will appear frequently in my talk, and okay, so let me in next slide, let me show you the definition of coherent algebra. We have several operations on the full matrix algebra of degree n over the complex number field. Let me say MNC. And for example, ordinary addition, and ordinary multiplication of matrices, and scalar product. And this guy is called Hadamard product. And Hadamard product is defined to be the entry-wise product. And this guy is sometimes called the bed student product. And the last one is complex conjugate. So star is the adjoint operator of the matrix of the matrices. And a subset script A of MNC is called a coherent algebra if this guy is closed under these 5 operations, and identity matrix and the all-round matrix belong to script A. That's the definition of coherent algebra. For example, please look at this guy, MNC. Of course, MNC is a coherent algebra because they are closed under these operations, and of course I am there belong to MNC. But the problem is, what else? Can you find any other coherent algebras of a given degree? Okay, can you find any other coherent algebra of degree 2? And are they finitely many or infinite? Okay.
What do you mean by degree?
Degree is size of a matrix.
So number 3 should be for all constant, no, all complex scalars.
Yeah, exactly. Number 3 is the scalar product of complex numbers. And okay, so before showing the answer, let me show you some property of coherent algebra. Sorry.
L.
Thank you for that. Okay, this is a list of properties of coherent algebras. Suppose that script A is a coherent algebra, and script it should be A. Suppose that A is a coherent algebra, then A is closed under the ordinary addition and ordinary multiplication of matrices and scalar product. It means script A is a subalgebra of MNC. And we have the following. And script A is just semi-simple. It means the Jacobson radical of A is the zero ideal. And Jacobson radical is defined to be the sum of all nilpotent left ideal of script A. But it is zero because of the fifth condition. Take an element of the take a matrix of the Jacobson radical of script A, then A star take an element of Jacobson radical, then A star must be script A. So this is also also radical, but this is Hermitian matrix and diagonalizable. It means A must be 0. So that's a proof of first conditions. Anyway, script A is semi-simple. And next we consider Hadamard product. Hadamard product is an entry-wise product, so associative and commutative. And this guy has no non-zero nilpotent element with respect to the Hadamard product, because Hadamard product is an entry-wise. So take the product of these guys. It is entry-wise. So the zero is the only nilpotent element with respect to the Hadamard product. In this case, we can use Artin-Weber-Barnes theorem. I hope you to remember this theorem in the course of algebra, in the course of algebra. And so it means script A is script A is semi-simple. So it is isomorphic to a direct product of full matrix algebras, and it is commutative. It means script A is isomorphic to some copies of the complex number field C. So it means script A has a unique basis consisting of primitive idempotents, and we shall denote it by script E of script A, or let me say EA. And okay, the third condition will give you a small surprise, because for each subset script S of MNC, there exists the smallest coherent algebra containing script S. Because take the intersection of all coherent algebras containing script S, then it also satisfies the definition of coherent algebras. And it means I think you studies combinatorics and graph theories, and I think each of you has your favorite graphs, like complete graph and path or tree, or what is a whole. So in this case, any graph has the adjacency matrix, and put here. So adjacency matrix generates coherent algebra containing it. So it means every graph has its own coherent algebra. So we can find the algebraic information from a graph. Not only a graph. You can take it D-graph and a set of D-graphs and a set of binary relations. Anyway, we can find such a coherent algebra. And now we shall define coherent configuration and association schemes. A subset S of MNC is called coherent configuration if script S is invariant from the following two processes. Okay, this guy is the smallest coherent configuration containing script S. So this is a generating coherent configuration, and E is choosing a unique basis consisting of primitive idempotents. So, okay, script S is if S satisfies these conditions, S must be a basis of coherent algebra, and S must be a idempotent with respect to the Hadamard product. Idempotent means square of A is A. It means all entries of A should be 0 or 1. So it means script S must be a set of 0, 1 matrices, and we call it and it is called an association scheme if it is a coherent configuration and identity matrix is belong to the script S. That's the definition of coherent configurations and association schemes. Okay, so this is a concrete example of concrete examples. Okay, I prepare 3 sets of 0, 1 matrices. Okay, okay, script S1 generates the full matrix algebra of degree 2, and the full matrix algebra has a unique basis of primitive idempotents consisting of primitive idempotents with respect to the with respect to the Hadamard matrices. So S1 is invariant from the 2 processes generating and choosing a unique basis. So S1 is a coherent configuration, but not an association scheme because identity matrix is not belong to this set. And second one is a association scheme because the script S2 generates the set of linear combination of these 2 guys forms a subalgebra, and the subalgebra has a unique basis consisting of 0, 1 matrices. So this is also changed by the 2 processes. But the third guy is not a coherent combination anymore, and because the script S3 generates the full matrix algebra, but the unique basis is script S1. So S3 does not coincide with the unique basis. So S3 is not a coherent configuration. And remark that if script S is a coherent configuration, S consists of 0, 1 matrices, as I told you, and such that the set of these guys closed under the adjoint operator, and the sum of these guys is equal to the Euler matrix, because Euler matrix is the identity with respect to the Hadamard product. So identity must be the sum of primitive idempotent. So we have these conditions, and in addition to this, it's necessary to satisfy the product of these 2 guys can be written as a linear combination of other matrices, because these guys are basis of a coherent algebra. It means basis. So it means the linear combination of these guys, the set of linear combination of these guys coincide with coherent algebra. So we need these conditions. Because of these conditions, S3 is not a coherent configuration. And if we have a coherent configuration, then we can take if we have a coherent algebra script A, then unique basis of script A is always coherent configuration. And these examples are how to say, good to be visualized, good to be visualized, but a little bit bored. So in next slide, I will show you some other examples. Okay, now we have a set of permutations, say script P in MNC, and consider the set of matrices which commute with each element of script P. So in other words, this guy is a centralizer algebra for Discreth of P. You see, identity matrix satisfies these conditions, and the all-round matrix satisfies these conditions because P is a permutation. P is a permutation matrix, and addition is also this guy is closed under addition and ordinary multiplication and Hadamard product because of the definition of Hadamard product. And in conclusion, we can say that the centralizer algebra is a coherent algebra, and so we shall a coherent configuration constructed by this way is called Schurian. This is the name of Schurian is derived from a famous mathematician Schur. So if you have so it means if you have a set of permutations, you have always a coherent configuration. And if P generates a transitive permutation group, this guy induces a association scheme. And let me show you another example. Platonic solid is a distance regular graph, and any distance regular graph induces an association scheme. It means if you have a distance regular graph, we have a distance matrices, and the distance matrices induces an association scheme. And association schemes of degree up to 30 are classified by computer search. You can see the list of enumerations in this homepage organized by Akihide Hanaki. And okay, please look at these numbers. I have should put the numbers from 1 to 10 over this place, and from the numbers from 11 to 20 over these numbers, and 21st to 30 and 31st to 34. And it means these numbers shows the number of isomorphism classes of association schemes of degree n. So please look at here. This is 1, and this is a number of association schemes of degree 2. So we have only finitely many association schemes over each degree, over each given degree. And please look at these guys. This is a number of isomorphism classes of non-Schurian association scheme. Non-Schurian association scheme. So we have 0 from 1 to 14. We have no non-Schurian association scheme up to degree 14. And this is the smallest guy. This is the smallest example of non-Schurian association scheme of degree non-Schurian guys. And so non-Schurian association scheme looks very exceptional, but it's it's never exceptional. For example, in the case of degree 32, we have more than half of non-Schurian cases, and it is conjectured that almost every association scheme is non-Schurian. So my interest lies in this point, and Okay, so in this slide, I will show you my interest on this research. Where is the boundary between Schurian and non-Schurian ones? Okay, Schurian association schemes. Okay, so is easier to be controlled because it is constructed by the group action. So in my eyes, Shurian association scheme looks how to say pretty girls, and in my eyes, non-Shurian guys looks bad boys. So I'm interested in the meeting point where bad boys, meeting point between pretty girls and bad boys. And okay, so I means this can happen. So we have. Okay, I showed the list of isomorphism classes, and look at here. We have how to say? We have many non-Shurian schemes and Shurian schemes with the same parameter. So this is a meeting point. We have the same parameter. Parameter means so this is a parameter. This is a structure constants of coherent configuration. We have the same parameter, but nevertheless we have thousands of non-Shurian guys and one Shurian guy. This kind of things can happen. So this is my interest. And okay, so and second is what can we say about the structure constants? And as I showed you, any distance regular graph induces an association scheme, and we have a lot of many intersection numbers, and it is known that many feasible conditions on the parameter many feasible conditions on the intersection number on the structure constants are known, well known, and some structure constants can be related to the orthogonal polynomials, the theory of orthogonal polynomials, and it's better to put the third and fourth and fifth condition into the same thing. Changing the field C into other commutative rings, we have another kind of ring, and from a view of ring theory, we can investigate such a algebra. For example, when is it semi-simple? When is it Frobenius? When what is the splitting field of this structure? This kind of things, and we have a character theory for association schemes. As I showed you, coherent algebra is a semi-simple. So we have a representation theory and irreducible characters. And what's the degree of the irreducible character, and characterization of coherent algebra by the degree or multiplicity of irreducible character. These kind of things are my interest. And okay, let me fix this one. This must be epsilon. This must be epsilon and A. It's not script A, and so the number 6 is more combinatorial, because this condition is translated as follows: finding a graph whose adjacency matrix can be a member of association scheme. Okay, association scheme is a set of matrices, and each matrix is a 0-1 matrix. So we have a D-graph to define AI. So association scheme is a set of graphs, and so I'm interested in which graph can be a member of association scheme. It must be I can say that it must be regular, but what else? And okay, so and today I will focus on this topic. This is automorphism group of association scheme. Here, let me show you the definition of automorphism group. For an association scheme script S, we denote by auto S the set of permutation matrices which commute with each element of script S. So as I mentioned, an association scheme is a set of zero matrices. So in other words, this guy is a set of digraphs, and each digraph has an automorphism group. The automorphism group association scheme is a intersection of all digraphs which appears here. Okay, so here, so now we are trying to find an automorphism under some assumption. Let script S be an association scheme of degree n, and without loss of generality, we may assume that A0 is the identity matrix. Then each AI has a structure, constant row sum Ki, called the balance of AI. It means this is a graph. So the balance, so this guy has a constant degree Ki. So this is called the constant degree Ki is called the balance of AI. And if each of the balance is equal to 1, then this guy is a set of permutation matrix and forms a group. And it is easy to find. It easy to prove this result. And the proof is a little bit technical. The proof is recorded in the first book of Paul Hermann Zishang. And if all balances are equal to 2 except the K0, then all graphs are regular graph of degree 2. It means only these kind of things, only polygon appears. So this is also easier to find automorphism group, but it's not so trivial. And the proof is given by Mitsugu and Zishang. And in the third case, if we have this situation, we have to think about trivalent graph, and not only trivalent graph, trivalent digraphs. But I think it's not easy to pick up which trivalent digraph can be a member of association scheme. So, but we have several algebraic conditions on this structure. So we can find this result. Automorphism group of S is Robin's unless n is equal to 4. And this is a result. This is a joint work with Kyung-Tak Kim and Zonle Park. And next, all balance is equal to 4. Then automorphism group of S is transitive. It is given by Zonle Park here. And in general case, we need to put these additional conditions. Thanks to these additional conditions, and if n is large enough, then script S is Shurian. It is given by, the proof is given by Mitsugu and Ponomarenko. Sorry. Okay, so this is my. Okay, so this is also okay. It is natural to ask about the case of balances 1 or 2, and I thought that it was started in 1998, and I thought that it was easily going, and all association schemes of this type are Shurian, but I was wrong. It was wrong. We found a counter example in this case, but in this category it is a unique one, and this is a characterization of association schemes of this type by the degree, and essentially and finally only two guys are non-Shurians. It is proved by Mitsugu and Ponomarenko. Essentially means each of non-Shurian guys constructed by a product of two guys and other trivial one. Two guys have degree 16 and 28. Okay, so this is my recent topic, and this is a case, but we can, how do you say? This is the first step to find a non-trivial automorphism. Non-trivial automorphism. This is the first step, but in this case, it's not. It's open to find such a non-trivial automorphism group, but we found some sufficient condition for an association scheme to have such a non-trivial automorphism group. And let me skip the detail. And okay, so this is our main theorem, and this is joint work, me and John Lepak here. And so this is almost the end of my talk. This is a list of references, and thank you for your attention.